I'm Chris Carmichael. I'm a sales engineer with InterSystems. And today we're going to talk about our implementation of the document database, which has a schema-less store, and our implementation in the InterSystems Iris data platform. And then first we're going to do a little introduction and then go into our implementation. So firstly, when we start thinking about NoSQL stores and what are they good for, there's two parts to that design. One is the data you're trying to model, and then the underlying structure that's going to support that model. So with these NoSQL databases, they're trying to take care of a performance issue, okay? And the goal of these things is speed and scalability. Now, when we do this in that storage layer, there's something we have to think about, and there's a theory out there called the CAP theorem, and by Eric Brewer, and it says, if it is impossible for a distributed data store to provide more than two of these three items, consistency, availability, and partition tolerance. Consistency says that no matter which server you hit, you'll always get the same data. Availability says that server will always be available, although that data might be stale, okay, as the data gets replicated from server to server to server. But that might be okay for your application. Partition tolerance, since this is a horizontal distributed data structure, you have to have servers that might fail, but the system always has to respond, okay? So that's thinking about it at that layer. So when you think about architecting a system, you have two choices. You've either got the AP type or you have the CP type, all right? So the availability and partition tolerance, your application would have to be able to tolerate old data as that data goes from server to server. Consistency, especially for ACID type transactions, that's the other style, okay? So each server has to have consistent data. You can think of cache with Enterprise Cache Protocol as a CP type system, as we use ECP to handle the consistency on the data servers, and the partition tolerance, we have mirroring, so the system will run while the mirror server takes over if something happens. The other thing that we think about is the data model, okay? That's the other thing that distinguishes these types of stores. There's different ways to model the data. Of course, we have the key value store, just a name and a value, and the document store, which we're talking about today, ability to store hierarchical structures. And then there's column stores, graph stores. If you've ever seen that chart with the thousands of databases and lines and things on it, there's a ton of them, but these are about the four major ones. Contrasting with the relational database, relational databases are great when you know the schema, data fits nicely in row and columns. In the late 1990s, Merrill Lynch did a study, and the study came back with that 80% of business data is unstructured. A couple of people called BS weren't impressed by that number and went off and did their own studies, and IBM did one, other PhDs and research institutes, but they all seem to settle on this 80% number. So really that means we've got maybe 20% of the data in a relational database. There's a big push on right now with these NLP engines to figure out what the unstructured data means, okay? So I just took this sentence out of a end-of-year fiscal report, right? There's still a lot of good data in there. You've got second quarter, when did it happen? Cherry Valley National Park purchased an ADA compliant bus for $200,000. So these NLP engines, what we're trying to do is take these things of interest out of these sentences and do something with it. We have an I know product that does exactly that, working with the concepts and relationships, okay? We've got Cherry National Park. That would be a concept. Purchased as a relating term, one ADA compliant bus. That would be a CRC kind of structure. We can aggregate these things through dominance and frequency types of analysis, marry that with discrete data, like you have in a row column table, for gender, location, cities. So you really start unlocking that data. But we still have to figure out how to store this kind of data, because it doesn't really fit neatly in a table. So a document database, that's what we're here to discuss today. And the structures that are available in a document database. We have JSON, binary JSON, or XML. And just language terms here, we've got a row from a relational table will be the same as a document. That's that autonomous thing that you're storing. Then a series of documents creates a collection. Those are the things that get sharded. And then you've got a column out of a table will be the same as a key in a document, and the value is still the value. Okay, so a little terminology there. In a document database, each record stands on its own, okay? Meaning that there's no referring out to other tables. You've got name-value pairs in there, you've got arrays, you've got objects, you can nest these things, you can create tree structures within these things. These items can get fairly complex. The other thing to note, documents are replaced. They're not updated. So you might have a value at a key level in a document. Rather than trying to find it, replace that value, just replace the document. Whereas as a relational database, you just change that value at that row-column intersection. Here's an example of a JSON structure. If you haven't seen it by now, you're new. We've got name value. All right, so we've got John Smith as our name. We have an object of address, city, state, zip, that sort of thing. And then we have an array of phone numbers, home, fax, and vacation. Nope, I could use one though. Let's see. So what are document databases good for? They're flexible. There's no schema involved. There's no database administrator creating something, right? You just store the structure. Sparseness, the data's there or it's not. Okay, that saves us on storage. Even in a relational database, that row-column intersection, if you have no data, it's still holding that, there's still a placeholder for that. That does take up room. Stores the hierarchical data, which we know. The keys and the values don't really have a type. Okay, so you have to think about that in your code. So if you have to work with something that does require a type, you'll have to cast that value into whatever type it needs to be. But that would be more of a coding function, whereas in a relational database, you already have that set. Relational databases, we're normalizing the data. We don't want to duplicate it anywhere, okay? So you're always trying to refer out to the data instead of keeping it all in one table. This creates an issue when we're talking about performance. When you're talking about huge amounts of data, the velocity of the data that's coming through, the amount of the data, okay? Just trying to store all this, we were connecting things in the internet. There's different types of information, and it's just coming across faster and faster. So in a relational database, we have to go out and write something. Sometimes you're writing to many different tables that might be across many different servers, so it's a multi-step operation. Similarly, when you're trying to read that data, get something back, it's also a multi-step operation. In some of these large, complex databases, you know, we all know how long our join list can get sometimes when you're trying to create that result set. Many steps to write, many steps to read. Here's the JSON structure. We're going to store this structure in our document database. See, everything is denormalized, all right? Autonomous record right here. Right, so it's a single write operation and a single read operation. What is this good for if you're doing mobile development, right? You have this, all the data's there. You send that out to the mobile device. It's sparse, a little bit there. And then all the mobile phone has to do is just write what you give it out to the user. So it's a much faster interface than, you know, maybe trying to transfer a whole XML document or waiting for an SQL query to finish. So just in general, you know, these different types of stores aren't there to replace, it's just to augment. Relational's here, it's going to stay. But use the right tool for the job. Relational's great when you need that query flexibility, ad hoc queries. Maybe you require a sort order for timeliness. And your performance requirements aren't the overarching thing that you're considering. In document databases, you can score that hierarchical structure, no schema, quick and easy to work with, always available, easy to scale. Okay, so just figuring out the right tool for the job. So that's all I wanted to say about, you know, just give us a little context for our next step of the discussion here. and talking about how we implemented the document database in InterSystems Iris. So to start out with, in our data platform, we have 4 models that we can work with. We have our multidimensional sparse arrays, known as globals too, or you might even think of it loosely as a hierarchical key store. We also support a relational model, object model, and now the document model. This gives us flexibility as the developers of applications. Now we just have one platform, many models to work with. We don't have to worry about plugging in third-party systems, creating the support around those systems to be able to utilize them. So how do we do this? On the server side, we've got %docdb package and the class name database. You can imagine takes care of all things database. Create a database, delete a database, find documents in the database. The document class takes care of that instance of the document. Okay? Last time it was updated, ID number of the document, so 1 through n kind of a store. As you put in documents, just gets the next number. Our REST, of course, is for the REST API. Related class, dynamic abstract object. So if you're working with JSON structures, they become automatically a dynamic abstract object. So what I'm going to do now is just walk through the code to create a document database, create some indexes, store the document, and then we'll go into finding the documents. So right here, got our %docdb.database class. We're going to use the method createDatabase. The argument is person, that's the name of my database. Hit return, you now have a document database. The next thing here are properties. So these are used to index the information in the document. So when you're making a document database, you're using that store to collect some interesting information. Then there's going to be interesting bits of information that people want to search on. What's the true important things you want to find in that document? And in here, this is where you would create the property. This property is then indexed, and when you do the searches, it makes those searches much, much faster. First argument is first name, that's what we're going to call it. Second is the data type. Third is the path in the JSON structure. And then the last argument, 0 or 1, is whether it's a unique index or not. Obviously, last name's not a good one to have a unique index on, but well, it's there. So we created the database. We put in 2 properties of interest, okay? And now, here's our JSON structure. So that's the demographic information. We've got first name, Thomas Anderson, out there. We've got his address, a couple of points of contact information. I'm doing this at the command prompt, so I just set that into the variable. That automatically creates a dynamic abstract object. If we want to work with some of these APIs, we have to make sure we turn into a JSON string, so we can use %toJSON method. Turns it into that string, and then the from JSON method will automatically insert that document into our document store. Another way to work with that, okay, a little bit easier. So once your document has been created, your document database rather, it'll go into the package isc.dm, okay? That's where it goes. And then your name of your document class, name of your document database will be the name of the class, okay? So in this case, we created that person database, and that becomes the class name. In there are 3 properties. You have your %ID, just the unique reference number for the document. You've got %doc, which contains the structure, and your last modified date. So those are the 3 properties to think about when you're storing your documents. So what we can do, we can just take that same demographic JSON structure, set it directly into %docdb, and since this is a persisted class, those persisted methods also work. And we just do a %save here. I've also written that out to the database. You can also delete things the same way. Then, we're finding documents now. So we're going to create an object reference. So we %get database, so I get my person database. Then I'm going to do a find. Now find has 3 arguments, which I'm going to go through. We have the %findDocuments method. So here we have a restriction. That's the first argument. It's in a JSON array. So first name is the property I'm working with. The value is Bill, and then equals is the operator. Okay, so the operators, % starts with greater than, less than, usual suspects. Then we've got, once that's executed, we can just write our results. And there I found my, my document. The second one is a projection, and that's just saying if I don't want to return the whole document, maybe I'm only interested in a few properties. You just give it an array of property names that you've indexed, and go ahead and execute that, and you get your property list with the values. And the last one, there is a limit, so you can limit the number of documents that's returned. Okay? And just managing the documents in the story, you have the %delete document method, pass in the ID number of the document you want to get rid of. So that's the server-side API. Here's the client side. What we have here is our base URL, which is my server address. Then I've got API DocDB v1, so we know that we're working with the document database. And then we have, what are the APIs we want to work with? So if I wanted to create the database like I did in the previous slide, I'm going to do an HTTP post. I've got my base URL, and then I'll have my namespace, which I was using samples, and I'll use the DB REST service. And then what do I want to call it? So I just put that on the end of the URL. If I want to delete it, same DB REST service. Actually, it's the same URL completely, just post, delete, and get. We changed the HTTP method. Want to create those properties. Instead of the %create property, we're going to use the prop REST service. So we've got our URL, service address, API DocDB v1, work with that database. Prop is our REST service. Samples our namespace, and then database, in this case, was person. Give it a property name, and our parameters of the URL. We're going to give it the type, the path, and whether it's a unique index or not. And similarly, to manage it, you've got the delete and get methods as well. In this example here, the save documents, we've got a post and a put. Notice on the post, there's a slash at the end. I spent an hour working out a 404, only to have to break down and read the documentation and find out I didn't have the slash. So don't do that. What we've got here is a post. Post will insert the new document using our doc REST service. We've got our usual URL at the top and the database name where we want to put that document. The put, however, requires an ID because we're going to replace that document. Then we've got different methods here. So we've got a put, a delete, and a get. If you want to get the individual document, all the same URL, but you just change the HTTP methods. The heck are they doing over there? So we're doing find documents. We use the find REST service. And this is where we can pass in that restriction to search for documents and projections, which I'll show an example. And it's the same URL, samples namespace, find REST service, database name you want to work with. So it's pretty simple interface to work with. So in this case, I'm doing a curl script here, passing in our user credentials, got some header stuff, and then we're going to post to our URL here. So I've got my server address, API DocDB v1, which is working with the document database. Samples is my namespace, find REST service. Continents is my document database. Return all of the documents in my continents database. So I've got seven continents there. Now, if I want to restrict that, okay, restrict my return, same URL, but we're adding this into the body of the HTTP, the restriction object with an array of property I'm working with, comparison value, and my operator. Give me everything that starts with A, and we've got Asia, Antarctica, and Africa as our return. So this is what it looks like after you've created your document database. We've got isc.dm as our package. Always have that when we create the document database. Our class name is wx. This is the one I'm going to show in a demo, just quickly doing some URLs. And here are the properties I was talking about, that interesting information we want to index. And I'm using the Yahoo weather service. And to get to city and state, I have to go through this JSON structure here. Okay, query, results, channel, location, and city. The state, they have a region since it's a worldwide service. I just called my property state because I was only interested in United States weather. And then we have our index references over here showing what properties we're indexing. Since we have that information, we can also use SQL to query the document database as well. And same idea here, you know, ISC_DM is my package, continents is the database, and in my where clause, give me everything that starts with A, Africa, Asia, Antarctica. That's just through the management portal in the SQL execution option. Demo. Okay. So I was going to run through a couple examples real quick of how you're going to work with this. Let's see, which one is this? All right. Bear with me a sec. I have all my scripts set up here. So the first thing I'm going to do is clean out my database. Oops, keep doing that. All right. Good. Okay, so the first thing I want to do here is delete this. And you can see I've got my server address here, the API DocDB v1, samples database. DB is the REST service, and WX is the name of my database. So here you can see in the return database WX, it was dropped, which is true. So I used the delete HTTP method. Now all I want to do is create that. I just change it to a post, send it out, and I get this back. And you can see the just created the document database. %doc is there. That's where I'm going to keep that dynamic abstract object, the JSON structure. The document ID is going to be the URN for each document that comes through, and my last modified date. So those are the three important properties out of here. Then, all right, I did that. So let's take a look at what the city property is going to look like. Okay, so same base URL, and then we've got, right before the parameter question mark there, we've got city, so that's the property I want to create. Type is %string, and then my path through the JSON structure to get that data, and it's not going to be a unique index. So I'm just going to send that out through my post. Return says I created it, and I'm going to do the same thing for my state. Okay, so I've now created the state property. Next, going to go out to Yahoo and get some weather. Now Yahoo's got an odd query language, and it has to be escaped. Oops, put that in the wrong spot. Right up here. Okay. So I'm getting the Philadelphia weather because I live outside of Philadelphia. And this way I know what to expect for tomorrow. Looks like 72 and mostly cloudy. Yay. Okay, so then I've got to post that into my database. So I need a URL to do that. So I'm going to have that URL with the slash at the end. Oh, doesn't matter. Okay, so I'm working with the WX database, have my slash at the end. I'm going to post. I just need to take the weather Make sure this is the right one. Oh, that's Tampa. I'll do this again, sorry. Okay, so it's going to pick up the raw XML there, copy that to my clipboard, and now I'm just going to put this into the payload in the body of the HTTP method, posting it, I send it out, and you can see right here I've just put that JSON structure into the document database. So easy enough to work with, right? So I got my Philadelphia PA there. So I'm just going to quickly get weather from Dallas. So you can see how quick you can work with this stuff. It's kind of fun. Oops, get the raw data. And then I'm going to use the same URL here. I'm just going to change what's in my body. It's supposed to be the weather from Dallas. Location Dallas there. So I've just stored that in the database. And then finally going to get Detroit. Okay. Yeah, all right. So we'll pop that in there. So in that amount of time, I've created my document database, created properties I want to index. I just got 3 weather reports and popped that into a database. So you can work with these things really pretty quickly. So now, let's say I want to find the documents. All right, firstly, I'll work with just a simple restriction, which is going to be, give me all the cities that start with D, and we'll pop that into our body, and then I think I just do that. Let's give it a shot. Nope. Okay. Oh, it's the find method. All right. Okay, so let me change our URL. Oops, where'd that come from? Okay, so now we're going to use the find REST service. There's our database, and now hopefully this should work. Okay. So now I've got Dallas, Texas, and I've got Detroit, Michigan as my return set after I've applied that restriction. And just to finish off in a similar way to the other example, I'm going to put in the projection. So my projection here, I've got just 2 properties, a percent document ID and the city. And of course, in the restriction, I've got the city, second value is D for what I'm comparing, starts with is the operator. Okay, so I'm going to send that out. And finally, I get my return. And you can see just returning Dallas and Detroit. So these are really easy to work with, really flexible, and you can do a lot with them very quickly. So that's it for the demo. Where's that thing? Oh, here it is. So in summary here, document databases, best thing on the planet since sliced bread, right? Flexible, scalable, agile, sparse, typeless, washes your car, it's all good. Okay, in our implementation, we're using JSON as our structure to store. We've got a server-side API, which is a %docdb class. We saw the REST API in operation, and you can even use your SQL on the index properties. So fairly flexible as well. Well, we're at the end of the conference, isn't it? I was going to say you could go to Tech Exchange and see some people. I guess they're still around. Stefan Whitman's the product manager. Dan Pascoe is the developer, and one of them, I think, or all of them. And of course, you can work with sales engineers like myself, or even Mike Hall, yeah. He knows all about document databases now. So that's what I have for you today, and be happy to answer any questions if you have them. Sure. On the microphone, please.
Do you know if there's any plans for using the documents for storing SDA streamlets in HealthShare? It sounds like an ideal candidate.
Good question. I don't know. I don't know. I don't work on the HealthShare side, so no. I wouldn't. Yeah, I don't know. I wouldn't think it would fit into the edge structure of the way we're storing the data, because the streamlets, we have special ways of dealing with the streamlets and storing the data and retrieving the data. So I'm not sure if it would apply or not.
Just stored as XML strings, you can see perfect to store them as JSON documents and documents tables.
Yeah, I would imagine it might just be that. Yeah, it's an interesting question. I'll have to check it out. Yeah. Anything else? Oh, this is on the IRIS platform. I'm sorry, InterSystems IRIS data platform. Okay. And that should be available, what is it, January, I think, was it? Okay. All right, if that's it, we can all go out and fry by the pool. Thank you.